The Kabanero open source project is also built on open source projects, and these come together to allow you to create more faster. One of those projects is a new innovative development environment and platform that aims to bring the simplicity of Cloud Foundry with the power, flexibility, and enterprise scale that you get from the Kubernetes platform. Today, developers and architects face challenges around the use of Cloud Native. Our enterprise architects, who traditionally work with application servers, now have to deal in the new world of 12-factor applications, understanding new ways of building applications and new environments and technologies that these need to work with. At the same time, our enterprise developers, who are traditionally used to building Java EE applications, now have to enter the new world of microservices with a much larger range of technologies and frameworks that they can choose from, and having to understand how to make those cloud native, including dealing with health checks and metrics and observability, and how to make sure that their applications interact properly and leverage the power of the cloud environment. This new open source project allows Champ to define his own opinionated platform. This allows him to choose the technologies that meet his needs, including dealing with existing decisions that were made before they adopted a cloud platform. From this, Champ can build a set of pre-configured application stacks that allow him to decide which languages and frameworks are used, how they are used, and how they integrate properly with his opinionated platform, allowing him to effectively build his own platform as a service or function as a service layer. These are then provided to Jane, our enterprise developer, who is now able to rapidly build and deploy microservices based on those pre-configured stacks that the solution architect has provided. Let's see how that works. Champ, our solution architect, provides his set of pre-configured application stacks, and these become available to Jane to use. Jane uses the CLI to discover the available stacks that she is able to use, either through the CLI or through a web interface. Jane can then create a new project using init, which gives her just her application code. She can then develop in her usual IDEs, whether that's VS Code, Eclipse, IntelliJ or others, and during that development environment, Champ's stack is dynamically pulled down and added to Jane's application, giving her an iterative development environment that uses both her application and the platform runtime stack that Champ has specified. Once she has finished doing development, she can save her changes, which again are just her app, commit that code to GitHub, and then from there that can be built. Let's see how this works. On the terminal, Jane is provided with a CLI. That CLI allows Jane to configure repositories. These may be open source repositories provided by the community, or a repository of application stacks that she can use that have been provided by her enterprise. From this, Jane can do app dev init to see the list of available project types that she can build. In order to build one of those projects, Jane creates a new directory for her app. Jane can go into that directory. From there she can type app dev init with the type of project that she wants to create, in this case Java microprofile. This pulls down a basic skeleton project for her to develop inside, as well as the stack that her platform architect has provided. From here she can open the project in any IDE that she chooses, in this case VS Code. Jane is provided with the project structure. This includes a README, a gitignore file, and just 2 files to provide an example of how to run an application. Inside this, she's provided with a microservice configuration file that shows that the microservice runs on the root URL, and a hello world file that responds with hello world to GET requests on /. This is a full development environment that provides Jane with code completion, syntax highlighting, and jump to code as she would normally expect. Additionally, Jane can run a build task to run her dev environment, and when she does this, it takes her application and adds it to the stack that has been provided by her platform architect and gives her an iterative development environment. Jane can then open her browser and see that the application is running. Now she is able to set up her browser to automatically reload and make changes to her project. When she saves those changes, the changes are detected, and the application is automatically rebuilt inside the development environment. This means she has an iterative environment that allows her to see her changes as they are made. Whilst Hello World is coming from Jane's application, she also has a number of features which have been provided to her by the platform runtime that her architect has provided. These include a health check endpoint, reports the health status of the application, as well as inbuilt support for OpenAPI. This describes the APIs that Jane is building and also provides a user interface through OpenAPI UI that lets her try out that inside her browser. It also provides inbuilt metrics through a metrics endpoint. This is designed to be used with Prometheus and Grafana, and Jane is able to run Prometheus in her local laptop. Once Jane is happy with her changes, she can build her project. The CLI provides a build command that allows Jane to set up or delete a Git hook and a CI/CD pipeline for her Git project, or to do a local build. The local build takes Jane's application and the stack that's been provided by her platform architect and uses the two to build a full microservice inside a Docker container that can then be used anywhere. This creates an image with the same name as her project, and she can then use that to run her application. This then starts her application in a Docker container. Jane can then go to her browser and see that fully running service running on port 8080. This includes Hello World along with the health checks that she had previously, the metrics, and the OpenAPI support. Jane has effectively been able to build a fully cloud-native microservice using only 2 files of her application code, with the rest of the cloud-native infrastructure being provided by her platform architect.